Welcome back to the classroom. My name is Mr. Wong. Today we're going to be looking at Module 8, Applying Chemical Ideas, for Inquiry Question 1, Analysis of Inorganic Substances. Now, last lesson we talked about flame tests. We're looking at precipitation reactions today. So, the lesson intention is obviously to find organic or inorganic substances. The method we're going to look at is precipitation, and obviously we're going to look at the different trends of precipitation to find these different types of inorganic substances. Now, just a quick recap. Last lesson we talked about the benefit of using flame test, and we credited the flame test from Niels Bohr's atom. The idea that energy states are quantized, and when an excited electron goes from a high energy state down to a lower energy state, releases a form of radiation energy, this in the form of visible light. We said that different types of chemicals will provide different colors, and this is what we see here. So these are the different trends we can see. Now, another method to doing that is by using precipitation. Now, just a quick recap on something from Module 5, precipitation and dissolution. So we know that water is an excellent solvent, and the reason being because it has it's a polar bond. So its polar component, so its positive polar component, can attach to negative ions. Its positive or its negative component, the oxygen, can combine with positive components of an ion. When an ion is surrounded by water molecules, we call it hydrated. Okay, so what's actually happening in terms of the bonding? We have the water molecule, which has dipole-dipole attractions. It causes a breakage in the ionic bonds of a sodium chloride lattice. Using sodium chloride as an example, that the hydrogen bonds from the water will break between each other, and we'll get some nice ion dipole attractions between the ions and the polar water molecules. This will help us form a solid, or the solid will form into an aqueous solution. So in that process we get the solid dissolved. And we also talked about previously the enthalpy and entropy considerations. We said that when you're breaking a chemical apart, the enthalpy will be positive, so it will be an endothermic process when you break the bonds. We also said in terms of the entropy, the greater the breakage, the greater the entropy there, because we're causing a lot more disorder in the solution. So that's like a nice little chart you can look at to look at whether or not something will become soluble or not. So the idea is when a solid dissolves into a solution, the energy of the bond it forms with water is lower than the energy of the bonds between the water molecules or between the cation and the anions in solution. This difference in energy will explain why some ionic salts dissolve in water and some do not. That's just a nice little recap. So let's look at what the value of precipitation is to analyzing inorganic substances. So we know the solubility rules. We know SNAP, the rule. Sodium, nitrate, acetate, ammonium, and potassium will always form soluble salts. We know that there are some exceptions with the insolubility, so hydroxides are usually insoluble unless we mix with particular groups. Same idea with carbonates and phosphates. We define solubility as the maximum amount of solute, a substance being the substance that's being dissolved, can be dissolved in a given quantity of solvent. The reference point is usually 100 grams or 100 milliliters. At a temperature of usually 25 degrees. So what's the value of precipitation reactions? Precipitation reactions, also known as a double displacement reaction, occurs when the cations and anions in an aqueous solution form an insoluble ionic solid called a precipitate. Now, each element, each ion has its own specific formation of a precipitate combination. So predictions can be made using the solubility tables. So you're given a solubility constant group in your formula sheet and data sheet, but you're not given the actual rules. So the rules you need to remember by yourself, that's not given to you by your data sheet. We can use multiple ions to identify a specific cation or an anion. So we can see these are all the different rules, these are all the different exceptions. These are all the ones for insoluble anions, and then the ones we have here are for the soluble, mostly soluble anions and cations. So there you go, there's quite a range there. So just before we get into some examples of where we can use precipitation to identify molecules, why don't you have a try of these two questions here. The first one, it says, determine whether a precipitate will form if we have a solution of potassium chloride and silver nitrate. If so, what's the precipitate? Question 2, determine whether a precipitate will form if we mix sodium hydroxide and a solution of barium acetate. If so, identify the precipitate. I'll give you 5 seconds just to pause the video here before I go on to the answers. Alright, so let's go through the answers. The precipitate you will form is silver 1 chloride, and there is no precipitate formed in our second scenario here. So some examples of where we can identify different cations or anion examples. Let's use the case of lead. So let's say I think the unknown solution I have is lead. Well, I'll know if I have lead or not if I react it with iodide. So when lead iodide forms, it forms a nice sort of yellow solid solution here. This actual reaction, we call it golden rain. So that's actually the color, distinct color of lead iodide there. So if you get that color, then that would, and you've reacted with iodide, then you would suspect that it is lead that you formed there. Obviously, additional tests can be done using flame test, but that's what we have here. What about iron? So iron can come in multiple valencies, right? It can come in iron 2+, it can come in iron 3+. Now, we can use potassium permanganate because when it reacts with iron 2, potassium permanganate goes from purple to transparent. So what we can see here, if this is what we see, then that would suggest to us we are dealing with iron 2+. If it's iron 3+, we could use potassium thiocyanate. Now this is actually back from module 5 when we talked about equilibrium solutions, and this was one of the examples we used. Now when potassium thiocyanate reacts with iron 3+, the solution becomes this blood red color. Okay, and whilst iron 2+ won't give you that same effect there. Okay, so that's how we can tell if we've formed iron 3+ in comparison to iron 2+, or if we have iron 2+, 3+ in our solution. Alright, so here's a nice little chart. Imagine we have an unknown cation and we add hydrochloric acid to it. If we do get a white precipitate, that could be lead or silver. If we get a yellow precipitate by adding iodide, we know we have lead. If we get another just white precipitate, then we know it is silver. You can do the exact same thing with the other cations. So by adding diluted ammonia and also adding fluoride into the solution. In terms of unknown anions, you could use red litmus test. So if you get red, you get sulfate, chloride, bromide, iodide, so the acidic colors. And then we can use, if it turns blue, we get these anions here. Further tests can be done, so you can add silver nitrate. If you get a creamy color, you get bromide. If it's a very light yellow color, it could potentially be iodide. And then you can separate it further with other solutions there. So that gives you a nice idea that using precipitation tests can give you a suggestion of what you have, but you will have to do multiple other precipitation tests. And you might even need to use things like a flame test just to confirm, at least with the cations. Alright, so that concludes the lesson for today. A good thing that you can look into is looking at different types of colors that flame testers make for particular cations and different colors that are formed from cations and anions in precipitation reactions. So hopefully this video, whilst it's been short, will give you a nice idea and appreciation of the different types of ways we can test and examine the presence of cations and anions in particular inorganic solutions. Anyhow, have a nice day and hope you enjoy the rest of the day.